We're now going to do the project for Module 11, built-in functions, which is just going to be completing the exercises. Let's begin with number 1. Create 3 different variables with 3 different data types, then use the type function to verify that the types are indeed different. So I'm just going to create 3 different variables. So we'll make A an integer, B could be a float, C could be a Boolean, and then I will take each one like this. Here's type of A. We can have multiple output on one line by separating things with a comma, and type C. All right, so int, float, and bool. That completes number 1. Number 2, before executing the following cell, determine the result of the following expression. Can you explain exactly what happened? All right, let's see. What is this going to evaluate as? So -5 raised to the power of 2, and then the absolute value of -5 raised to the power of 2. So it's very similar. This is actually going to evaluate as false. You might think, well, -5 squared is 25, and then the absolute value of -5 is 5, which squared is 25. So you think they might be true, but they are actually false. What happens here is that -5 squared is actually -25. Python evaluates this first. It treats the negative as an operator, and exponentiation has a higher precedence. So if you think about it like this, 0 minus 5 squared, that might help you out. So the 0, doesn't really do anything. Just treating this as a minus sign instead of just a negative sign can help you determine that, oh, okay, the exponentiation is actually first. The trick here is to realize that this is not, this is actually an operator, and it's not really part of the 5, even though it's right next to it. I know that's really kind of bizarre. Another way to see this, or a way to get the answer that you're looking for, is to say, all right, let's just do -5 first. Let's make this quantity -5, not just 5 with a negative sign out in front. This is now -5 squared, which will be 25. All right. Number 3, add the minimum value to the maximum value of the following list. Okay, so here's a list with some elements. This one is pretty easy. We take min A, and we're just going to add it to maximum of A. And there we go. Number 4, round the number, I'm not sure what this is, 23,482,734 to the nearest million. Let's copy and paste this to the nearest million. So rounding it by itself rounds it to the nearest integer. Well, it's already an integer that does nothing. We have to round it to the nearest million. We have to go backwards. That's 6 decimal places. So this will round it to the nearest million if we put in -6, so 23 million. Exercise 5, the eval built-in function takes a string as an argument and executes that string as if it were Python code. Create a variable that stores a string that looks like Python code, then use the eval function to execute this code string. So we didn't talk about the eval function, so this is something new over here. This is just seeing if you know how to use it. So the source, it will be a string containing a Python expression. So this is kind of weird. So let's just say, let's keep it simple. We want to evaluate 5 plus 4. So you have to make it a string in here. You do 5 plus 4, and it will evaluate this string. So if you have code that's inside of a string, so you have Python code that's inside of a string, you can actually evaluate it with this eval function. You have to be very careful using this so you don't arbitrarily execute someone's string that could be malicious. But so it is available, and that's how you can execute code that's within a string. So this is pretty rare, which is why it was not brought up in the main material. Exercise 6, create a list with 4 objects of all different types, such that passing this list to the any function evaluates as false. So again, the any function, the only way to make it false is if all of these are false. And let me put this in its own line. We'll just say the variable A. So we have a bunch of false items. Now, it says to create 4 all of different types. So we can make one of them false. 0 is also treated as false. The empty string is false. An empty list is false. The none object is also false. I know that is 5. But sort of anything that is emptiness is false. You can have the float 0.0. That is false. So if we pass in this list, all of these are false. They're all different types. And we'll evaluate the whole thing. So none of these are true. If we had one of them to be true, so say just a string with one character, well, that would be treated as, well, that's true. So are any of these true? Yes, this one is true. Let me go back to the correct answer. Number 7, sort all of the characters in the following string from least to greatest, creating a new string. For example, Python would become this from YTPONH. Hint, use the string the join string method. Okay, so there's no following string. Let's just put one here, and we can put some string. Let's just say list comprehensions like this. So here's our string, and we can sort this using the sorted function. So this will sort it from least to greatest, but we don't want that. We want the reverse to be true. So remember that, we press Shift Tab Tab. We can sort it in reverse order, make it true. So now that's what I want. Now the issue here is that I want to connect, I want to join them all. That's what it says, use the join string method. So a trick here, you have to know about the join string method. So if you have a string, and you can call methods from strings that you just declare like this. So this will look very bizarre. And I can do this. So this says, hey, this is a string, it's an empty string. I'm going to call the join method. And what am I going to join? I'm going to join this list. So I'm going to join all of these into one string like that. Okay, so this is a little weird when you first see it, but you can call methods like this, just like, let me just do another one. Let's just say Python. I can do dot upper like this, and it will execute. So that's weird to call a method like this. Normally, you say s equals, some string like this, soccer, and then you say upper like that. But in this case, you can just go directly from the string itself. All right, exercise 8. The Russian alphabet spans Unicode code point 1072 to 1103. Print out each character, and then place 10 characters on one line before moving to the next. We're going to print out each character. So what you need to do here is iterate through each one of these numbers, so 1072 to 1104. And then what we're going to do is, if we have the code point, we use CHR to print out the actual character over here. So here are all of the characters in the Russian alphabet. Now, what we want to do is we want to place 10 on the same line. So if you remember, the end over here is by default a new line character. So if we make it, say, a space, it will print them all on one line. I said to place 10 characters on one line before going to the next. So how do we count 10? Well, here's a little trick. We can say if I divided by our modulus 10, so this is the last integer. If the last integer is 1, and the reason I'm saying 1 is because it starts at 72, so 1072, the last one is 2. So to get to 10, it would go, 72, 73, 4, 5, 6, and finally it would reach, 81, and then we would have a new line character. So we'll just have an empty print statement here, which will say, all right, just go to the next line like this. And so there we go. So it'll put out 10, and then this will be true, and then it'll go to the next line and so forth. Okay. All right, good. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, great. All right, exercise 9. How many quarters and pennies would it take to make $134.98? Use the maximum number of quarters possible. So how many quarters fit in here? Well, yeah, you could do the math yourself. It's not too hard. Yeah, but we can I want you to use div mod here. So 134.98. I'm going to divide it by 25 cents. So 0.25. How many quarters go in there? And then this will give us the number of quarters, and then the remainder will be pennies. So 539 quarters, and then we are left with 23 cents. There's some rounding. This is just due to float and precision, which I have not yet talked about. But if you see all these nines right here, essentially this is just the same thing as 23 cents. So that'll be, when you get to 75 cents, then 23 cents will be added up to 98. So again, that's 539 quarters, and then 23 pennies. Another way of doing this is just to multiply it by 100, and so this will be a little bit easier to read. So this is like, say, the number of pennies total, so 13,498, right, total cents, and then 25 cents for each quarter, and this is how you get whole numbers. So this is actually just a cleaner way of looking at it. All right, number 10, sum up the integers 1 through 100. Well, the easiest way to do this is with the sum function, and then the range object, we can create that range, actually 1, 101, and that will sum it up. So this is a sequence of just the integers 1 through 100, and that's what the sum function is used for. So iterating through them with a for loop is possible, but just a lot less efficient than just a simple line of code. Exercise 11, create a list of 100 random integers between 1 and 1 million. Find the min, max, and sum of this list. Okay, so I'm going to use a list comprehension here, and I'm going to import the random module. So I have to create a random integers between 1 and 1 million. And I'm going to use a list comprehension, so for I in range 100. All right, so here, you have to remember list comprehensions. We'll put the for loop on the right-hand side, and then the expression over here on the left. This is just generating random numbers between 1 and 1 million. That creates 100 of them. Let's go ahead and look at them. So here's that list. And then all I want to do is find the min, max, and sum of that list. So this is the minimum value, maximum value, and then just the sum. All right, moving on to number 12. Verify that 3 raised to the power of 11 is the same using the exponentiation operator as it is using the POW function. Okay, so we're just going to verify that this is the same. So here's 3 to the 11. Here's POW 3, 11. That does the same thing. You can do this in one line and just verify equality like this. All right, great. Number 13, print out all of the public attributes and methods of a list. Public names do not begin with an underscore. All right, so print out 3 names on each line before moving on to the next. All right, so the way to do this is with the dir function. We can just create an empty list right here. And if we do dir of A, we'll get all of the attributes and methods. I'm just not interested in these ones that begin with an underscore. These are the private ones. I want the public ones, these down here. So we can filter for these. And I'll do it. Let's go and print through. Let's go iterate through here. So for name in dir A, so I'm going to iterate through this. And if the name starts with, if the first one is an underscore, like this, actually I should say is not an underscore, then I will print out the name like this. So this will filter for just these ones that do not begin with an underscore. And I said print out 3 before going through, before separating, before going to the next line. So we'll make the end just a space like this. And so what we'll need to do here is, if we want to print only 3 and then go to the next, we'll have to do something like this. So we have to keep track of how many are printed. We'll just increase this I by 1. And if I divided by, if the remainder is 3, then we will print a new line like this. And you can see this did not work, so there's an error here in my code. And this should only be in this loop, in this if statement over here. I did it for every one over here. So we saw there's many names. We only want to check when we're actually printing out. So now, once I get to 3, I'm just counting up. Then it'll go to the next line and just do a normal. So this print statement will just print a new line. Okay, so that is 13. 14, verify that the length of range 100 is 100. So when I create this, how do I know there's actually 100 items here? Well, I can just pass this in directly to the len function and I get back that it is 100. All right, exercise 15, create a list and assign it to a variable. Make a copy of the list and verify that the ID function returns a different value for each variable. Okay, so this is pretty simple. We're just going to create a list. And then I'm going to create a copy. And now I'm going to use the ID function to find the ID of each. And we can see that they are different. So they are completely separate locations in my computer, although the values are equal. So that is not a problem, but they are just 2 independent lists just in a different place on my file system. All right, or my memory. All right, so that is all of the exercises 1 through 15 of Module 11 built-in functions.